Hello everyone, welcome back to Aaron's Shop Notes. Today we're going to be installing a DRO on both the lathe and on the mill. We're going to be installing a TouchDRO, so should be a fun project. We'll go over what the TouchDRO is, what scales I chose, and how we're going to mount the scales. It should be fun. Also, I bought a mic, so hopefully I sound better this time. So for the DRO system on both the lathe and the mill, we're going to be going with this system called TouchDRO. If you don't know what it is a system made by a guy named Yuri. He's very involved in the makerspace community. He's involved in the hobby machinist forums, and he's been working on this project for a while. So as you can see here, it's a powerful touchscreen DRO for lathes and milling machines. So it runs off of an Android-based tablet. That can be an actual Android tablet, or that can be an Amazon tablet. And you can see sort of the interface here. There's a lot of customization on the interface, and there's a lot of features, a lot of really cool features that either you don't get with DROs, typical DROs, or they're pretty high-end features that you only get with more expensive DROs, and it's hard to learn the interface. And this allows you to customize a lot of things and allows you to do a lot of very cool things. Overlay images of the CAD that you're making, like you can see here, bolt hole patterns, all of that. So it is a pretty cool system. On here they have a lot of documentation about what you need, how you choose your tablet, how you choose your scales. Scales wise, I went with Acron scales right here. He has them linked, he talks about them. He talks about a bunch of different ones and recommendations in different price ranges. So you can go ahead and choose what works best for you. Again, I ordered straight from Acron. I think that's how it's pronounced. And then if you go there, you can go ahead and browse all their products. I went with a combination of magnetic and glass scales for various reasons that we'll get into later. But the good part about TouchDRO is you can mix and match them without any issue. The other cool thing is that you can do stuff like touch probes, and you can do encoders for spindle speed. There's a lot of cool stuff here. I recommend that you, if you're considering a DRO, go read through the TouchDRO documentation and see what you can find. You this is not the most cost-effective option, not by far. With a lot of the kits that you can buy from China nowadays, you can get them pretty cheap, and this adds up. You have to buy the DRO unit, which is $300 for the mill, $250 or $260 for the lathe. There is cheaper options if you want to do a little bit of soldering yourself and you're okay with a slightly less powerful product. But again, you need that, and then you need to go and buy your scale. You need to go and buy your tablet if you don't have one. There's a lot more cost involved, but I think with the features you get, especially for a mill, maybe less so with a lathe, I think it's worth it. So we're going to actually go dive into the features once it's set up, but that is a bit of the reasoning for why I chose the TouchDRO and the scales that I chose. So let's go ahead and unbox it and look at what came in the box, and then we'll take a look at the tablets I chose. All right, some connectors. A nice pen that's labeled TouchDRO, that's nice. And I'm dropping everything. And then the DRO units themselves. These look very nice. So we have one for the mill, one for the lathe. They have inputs for up to 4 axes each of them, and then they also have an input on the mill for a tachometer for mill spindle speed, as well as a probe. You can have a touch probe that you use with it. As well, then on the lathe, you have just the encoder input for the spindle speed if you want. And I only need 2 axes, but I got the one with all 4. Now, the one cool thing for the mill is we're going to be able to configure axis summing for the Z-axis and the quill. And yeah, we'll go over some of the more features once we actually have it in place and attached. But basically, you choose your own scales. It's compatible with a whole bunch of different scales. You choose and install your own scales, and they plug into this, and then this acts as the Bluetooth interface between the tablet and this for your DRO scale. Now, to actually mount these to the machine, I have these. I did not design these. This is from James from Cloud42. He designed them and made them available to his Patreon members. Thank you for that. Because of that, I will not be releasing the models for these, but if you want to get these, go ahead and support him, subscribe to his Patreon, and you can look up TouchDRO on his Patreon, and he'll have them there. But the way this works is this replaces the back face on here. Mounts to this, and then we can tap holes in the machine or on the wall, wherever we want to mount this. So let's go ahead and get this installed onto here. So as you can see, it just comes off of the old back onto the new back. Looks like he 3D printed this one also. Or then the old cover just pops on over it, and the same screws are used. Very cool design. Thank you, James. Beautiful. Let's go ahead and do the second one. All right, and just like that, we have two ready to go, ready to mount to anywhere we want on the machine with strain relief for the cables and the encoder attachments and all of that. Very cool. All right, so this is what we're working with for the actual interface to the DRO. TouchDRO lets you use an Android tablet or a Fire tablet, an Amazon tablet. So the way this is going to work is that I have this Amazon Fire HD10. I got it refurbished for about $70, I think, and this is going to be plenty strong for the application. So I wanted a way to house this and a way to mount this close to the machine. So I went ahead and I designed this case for the tablet. I printed this on the Bamboo Lab X1 Carbon, and I printed it out of PETG. It took a while to get the design right. It went through a few iterations until it would print correctly. And you still see we get a little bit of stringing here. It didn't print perfectly, but I think it printed good enough for our application. I'll make this file available if you want it. There were a few designs that I found online already for a case for this Fire HD10, but for what I wanted, I kind of had to make my own because the ones that had what I wanted where someone used it for a TouchDRO in the past, the issue is that they had used it for, I think, the 2019 version of the tablet, so the size changed slightly. I couldn't find a step file for it to modify, so I just had to design my own. Cool little features here. I got this little cutout for the cable, and there's a right angle cable that I'm going to be using right here. So this will go into the tablet, and then it'll run along the side of this cable. And with that, that means that it can run out the backside, and you won't be able to actually see the cable. Then I also have threaded insert holes, so we're going to go ahead and attach threaded inserts here, and what we're going to do there is that these are 100mm by 100mm spacing for a VESA mount. So the tablet for the lathe is just going to get mounted next to it on the wall, and then the tablet for the mill is going to get mounted to the mill itself. You're going to have to drill and tap some holes. To attach these two sides together with the dovetails, what we did was just two little holes. Again, threaded inserts are going to go in there, little M3s, and it should go together nicely. So let's start assembling. If you've never seen these heat set threaded inserts before, they're pretty awesome. They're a great way to make threads in 3D printed parts without worrying about stripping out the plastic. The way it works is in the design, you just size the hole for the correct size insert that you want to use. There's design guidelines online for that. Then you press them in with the soldering iron. So that's what we're going to do now. So for these, I designed them for M4s for the VESA mounts. So I'll just take my M4 inserts, push it into the hole there, size so that just drops right in place. Then we take our soldering iron, which I preheated. It has a special insert for it, and it just presses down on top. Now the only worry is that it's flush. Make sure it's flush, and you also want to make sure that it threaded in straight. So the easiest way to do that is while it's still hot, take your bolt that you're going to use. Again, I'm using an M4. Thread it in, and you can still make a little adjustments while it's still hot. I also like to do that to clear out any plastic that might have melted into the hole. And then it'll just dry like that, or it'll cool like that. So let's go ahead and do the rest of them. And then to hold it again together, again, we have these two holes here. Actually printed very impressively without support. But we're going to go ahead and put our M3 supports in there. So this right here is why it's always good to thread something in while it's still hot. It seems that there's some plastic stuck on the back side there, so it's either plastic or the hole is a little collapsed in there. So I'm going to go ahead and just drill that out a little bit. Yeah, there's just a little plastic caught behind it. All right, let's go ahead and get ready to assemble it then. That's just beautiful. That looks great. A little bit of a gap, but I didn't want to over tighten these threaded inserts too hard, or else I'd be afraid to rip them out. But really, I mean, that looks really good. Cable comes out nice and smooth. You can still access the power button if you need to. Then if you go ahead and take the mount, this will be for the lathe. Because it only needs to articulate in and out, it's going to be right above the lathe, whereas the mill I'm going to have a third axis so it can move up and down. But this will just attach back here. That's amazing. It looks really good. I'm happy with that. All right, so I'm going to go and do the same thing for the second tablet, and we can check back when we're ready to mount it on the wall into the mill. So what you see right here is a model of the lathe, at least the important portions for the mounting of the DRO. I started with a model, again, from James's Patreon. If you want that model, go and download it. I'm not going to provide it because that is not my place to do so. But it was just a starting point. I had to make a lot of modifications to match my actual setup. The castings was different, some of the dimensions were different. So basically I went through and changed a bunch of things, but the base itself was from his step files. So thank you for that. We're also going to be borrowing his idea for how we go about mounting the scale for the cross slide. The cross slide is the hardest part for these small lathes because there's so little space. So the way we're going to be doing it is that this right here is a magnetic scale, and there's just enough room to sneak in M3 screws here without damaging the electronics. So we're going to go ahead and cross drill that for M3 screws, and then we're going to take the cross slide itself off of the lathe, and we're going to drill holes and tab holes for these M3 holes. And then the way we're going to actually mount the reed head is this space right here is rough casting on the actual machine, but what we can do is we can machine it, which is the same thing that James did, and then make a bracket to attach the reed head here. Now, this modeling process was actually fairly in-depth in terms of taking all the measurements, and then I didn't have the actual scales yet, so just reading the drawings and putting it in place and designing a mount for it was actually a pretty in-depth, fun process. So if you want to see how I went about doing that, let me know and I can make a video on that process alone. But I wanted to make it so that we could use, for all of our mounting points as much as possible, I wanted to be able to use plate that I can order from Send. Make it as easy as possible for anyone else to follow along with this project if you want, because I can just give you the DXF file. So how do we do that when this reed head needs to be at a very specific distance as well as location compared to the scale? Well, plate only comes in very specific thicknesses, right? So what we could do is we could machine this face here to be an exact distance so that we can order a plate in the exact distance we need. The way this one is 6.35 millimeters or 1/4 inch. And so what we do is we're just going to, when we machine the saddle itself, we're going to machine it so that with a 1/4 inch plate, we're at the correct spacing relative to the scale. Because we have to machine this anyway to get a flat parallel surface for the mounting, might as well do it this way rather than make our own bracket with some random custom size. Now that gives us a machined surface that will be parallel to the scale, and this is parallel, we know that. So 2 machined surfaces, that's good. So all we need is adjustment up and down. We have that both on the reed head itself. The reed head has little mounting hole slots, and we also have reed head, we have holes here, slots here for mounting the bracket itself to this plate. So that's the plan. Machining needed. We need to take off the cross slide and drill and tap M3 holes. We need to take off the saddle and machine this portion flat to a specific height relative to this face. Drill and tap holes to mount this bracket. Then we need to drill a clearance hole here for a bolt that will be used as a stop for the tailstock, so the tailstock can't run into this. The Z-axis is a lot easier. On the back of this, the saddle, we're just going to take it off. When we have it off, we can drill and tap holes for a bracket. And then this bent sheet metal bracket here will hold the scale. We'll hold the reed head. The scale itself will just be mounted to the casting. We can drill and tap holes with it still, in the casting on the machine with a drill. That'll be nice and easy. And because we have adjustability, both inwards and outwards here, as well as up and down, we have all of the adjustability that we need to actually make sure this is aligned. This here is actually a glass scale. I went with glass scales for everywhere I could, which is everywhere except for the cross slide, because I don't need the space savings of magnetic scales, and glass scales are a whole lot more forgiving in terms of mounting. So it doesn't have to be perfectly aligned. And so the adjustability that we have should be plenty. As long as we get this mounted fairly level, we can use a dial indicator to do that. And then this will have enough adjustability in these slots to get that mounted. Again, this is a sheet metal component we're going to order from Send, and I can provide that DXF, so anyone can do with that what they will. But for prototyping, all of these parts will be 3D printed. Once everything is confirmed to have worked, I'll go ahead and order the parts. So let's go ahead and start in person at the mill before we move to the CAD. I think it'll make things make a little more sense. 2 of the axes should be pretty easy. 2 of them are a little more difficult. The one of them that will be easy will be the x-axis back here. So as you can see, there's already a scale on the x and y axis. We will be replacing those because they are not working correctly. They came with the mill and I think they're damaged. It's a shame. They're accurate. They're very expensive, but they gotta go. So this is one of the easy axes. X-axis, we just have 2 parallel surfaces between the table and then down here, saddle. So what we're just going to do is we're going to copy the mounting that's currently here. We're going to drill and tap holes for the reed head, or maybe we can use those same holes. Then we're going to drill and tap holes for the scale. The scale will travel back and forth, and the reed head will stay stationary. Because those are parallel surfaces, that'll be nice and easy. We just need a spacer so that the reed head position is correct inwards and outwards relative to the scale. Same thing for the knee. We can just drill and tap into the casting here. Nice and easy with a spacer. Now it gets a little more complicated with the y-axis here, but not too bad. We're copying this idea of using using a L bracket, a bent sheet metal bracket, and we're going to use these two mounting holes here. So that will hold the scale, which will move back and, or the read head, which will move back and forth. Scale is stationary, will be drilled and tapped into the casting here. Now, the hardest axis by far is the quill. So here's the idea. We have this nut here that rides up and down with the quill as it moves up and down, right? So that is how we're going to hold the reed head. I'll show you how we're going to do that, but I've got an idea for using that nut without having to make a new one. Now, if we're going to hold the reed head there, right, we need a way to mount the scale. And as you can see, it's moved out quite a bit from our mounting holes. This is a lot of complicated geometry, a lot of stuff to copy over. It took a lot of iterations to figure something out, a lot of 3D printing prototypes, but I think I got something. So the key here will be these two mounting holes. These are threaded holes. We can use these to mount a spacer to, and then the bracket. So let's go over to the CAD and I'll show you how we're going to do it. All right, here's the spacer I was discussing for the x-axis and the knee. If you go ahead and take a look at the scale I'm using, you can see the spacing here. They're not quite lined up in this direction. You need a little bit of a gap. What is it? A 2 millimeter gap from where the scale is mounted and where the reed head is mounted. So I just went ahead and designed a spacer here, which I'll 3D print, and we can use that for both the x-axis and the knee. That one's nice and easy. Moving to the y-axis, here is that bent sheet metal bracket that we were discussing. We have adjustability inwards and outwards that way, as well as up and down. So that should give us, as long as this is close to 90 degrees, that should give us the adjustability that we need. Again, all of these are glass scales. We're only using magnetic on the cross slide of the lathe. Because of that, we have a lot more flexibility in making sure, not having to make sure that they're within a thou across the entire surface or anything like that. It's a lot more flexible. So that's the plan here. Here is what we're doing for the quill. So here's the nut that we went ahead and designed to model after the current nut. We're just going to take that off and modify it so we don't have to make a new one. What we're going to do is we're going to put a slit across it, then we're going to drill a hole, and we're going to tap the bottom side. So that way we have this 3D printed bracket here, or in the future we can machine that if we need to, but for now it'll be 3D printed, and that has a slot in it, and we can just clamp down on the slot. And this bracket will allow us to travel up and down as the quill moves, and then attach to the reed head here. The reed head is spaced off the correct distance from the scale. Again, this required measuring and a lot of iterations 3D printing to make sure that we can actually move it correctly and get it in position correctly. Again, we have movement this direction because of a slot in here. And then we have movement in this direction, outwards, left to right, and because of slots on the actual mounting bracket. So that should ensure that we can get this perfectly lined up with where it needs to be for the scale. How are we going to mount the scale? The scale mounts to this 1/4 inch sheet metal piece. Again, it will be sheet metal. Right now it's just 3D printed to make sure everything fits. 2 tapped holes here, which again gives us left to right movement through these slots on the scale. Nice and easy, right? Then that mounts to our spacer with these countersunk bolts. I believe these are, M4s. So these attach to our spacer and let the scale sit flush against it since they're countersunk. Here's our spacer. This will be a 3D printed component, but it can be machined in the future if it needs to. I think this should be plenty strong 3D printed though. It's just a spacer. I believe the scale bracket though, this will have to be sent off to Sencut Send. So here's our spacer. The inwards and outwards is correct to put it in about the right position. The thickness, we have countersunk as well as, counterbored, as well as slotted holes here for mounting to those 2 tapped holes that I showed you on the quill. That'll make us so we can move it up and down wherever it needs to go. Then we have these 2 holes which are going to be tapped with heat set inserts for attaching the scale bracket. That is the plan for the quill. We'll see how it works in practice, but that is the plan. It should be nice and compact. This keeps it on one side, and I should not get in the way of anything from my measurements and from the 3D prints. So let's go ahead and get it attached and take a look. So unfortunately, that's all we have time for today. That and the fact that my scales have not come yet. They should come a little bit later in the week, hopefully tomorrow, so we can get started working on that. But that will be all for today. So in the next part, we're going to actually get mounting the scales to the lathe, and then to the mill, and then we'll get the tablets mounted and we'll take a look at some of the features. There's going to be some machining and some fabricating, and hopefully I don't break any taps off in the machines. It should be exciting. But if you're interested, go ahead and like and subscribe and take a look when that video comes out. Thank you for watching, and I hope you learned something in this and you maybe can follow along and do this project yourself. Thank you, and see you next time.